Welcome to another tutorial. In the last episode, we built our first behavior tree. If we go down to blueprints into the AI folder and open up BT_enemy, this is the behavior tree we designed. So upon entry, this selector will pick the first thing on its left, which is our test2 script, which is just firing off this print string here. Now, this sequence here is checking this blackboard value, which is over here in the blackboard. This blackboard value is set when our AI can see hero. So if it's not set, we run the where'd you go script. And when it is set, then this will go over here into test1, which is the script essentially for I see you. And seeing that in action, we can run up there and we will get an ICU once that task has finished executing. So let's start right there. If the behavior tree is waiting here, it doesn't stop and change back over to this once we see it, and we have to wait for the sequence to finish. If we don't want to wait for the sequence to finish, we can actually select the blackboard key, and here you can see observer aborts. And we can select abort either itself, low priority, or both. So if we select self and save that, we'll pop over here. And then you can see it says, I see you. So it aborts itself once the condition is changed, but it didn't change back. So now if we click on this blackboard key and select self and save that, then every time we walk in, I see you, where'd you go? And that was happening irrelevant of what the actual sequence was playing. So the sequences are essentially aborting themselves when the blackboard key changes. But that's not what I want to actually do today. I want to fill one of these events out. To do so, we're just going to focus on just one sequence. So I want you to hold Alt and click this arrow here. We want to disconnect this event over here. We don't need this event for the moment. We're going to be focusing on this sequence, which is essentially going to be the patrol behavior. If you haven't already, open up test2. The first thing we're going to do when we're patrolling is get a location. So move these guys over. We'll actually get rid of this print string. We don't need that. We're going to drag off controlled pawn. We're going to get actor location. Then we're going to get random point in navigable radius. And this is essentially just going to get the location of the actor and get a random point. So let's punch in a random value, say at 1000. What we could do at this point is get AI move to. AI move to is exactly what it sounds like. It's going to move the AI to the location. And we just punch in the pawn and we punch in the destination. And on success, we finish execute and we're done. But that's not what we're going to do here. We're actually going to separate the events. So getting the point is going to be the first event. So once we have this point, we're going to, first of all, check if it's valid, check if it actually worked. And then we're going to come up to variables here, hit the plus sign and type in location key. We're going to click the drop down for variable type and type in blackboard key selector. And then we'll drag that in, compile and save, and set value as vector. So essentially what we're going to do is save a coordinate, whatever coordinate this task comes with. And the reason we're keeping this separate is, first of all, in case it fails. If it fails, then it's not going to get hung up. If we have this in the one task, it's not necessarily going to know to repeat itself without us brute forcing the script, essentially running false back into the beginning of the event. We don't want to do that. We just want to get that key and set it. And if we can't set it, then we're going to consider that a failure. And this is where we'll use the finish abort. But we shouldn't need that. This doesn't often fail, but it's a good idea to keep this here. The value will plug in here, and once that key is set, we will plug in the blackboard value as a vector. And there we go. That's the first event, and we need to go and name that event accordingly. We will call this task not just T, because T is normally reserved for textures. So we'll start calling it task underscore get location. And then we'll move on to this one. So let's get rid of the ICU. Right click anywhere and type in AI move to. And we'll punch in pawn into controlled pawn. We'll also get a finish abort. Because we have a success and a fail here, so we can punch them both in. Again, unlikely that it would fail, but we just want to make sure that we can account for as many potential problems as possible. Now the destination, we need to get that key. Come up to variables again, type in location key. And this will be, once again, a blackboard key selector. Then we will get value as vector and punch in that destination, just like so. Now these two variables from this script over here to this script aren't talking to each other just yet. So with that set, let's compile and save. Let's go over to t_test1 and change this to task underscore move to location. Now you might notice or remember that if you're in the behavior tree and drag out here and click the drop down for tasks, there's actually a move to already here. The reason we're creating our own is because we want to have the flexibility to have more options, and I'll show you an example of that in just a moment. For now, let's get rid of test 1 and test 2 so that they can update. We'll get rid of that wait as well because that script will change entirely. Let's get our tasks, get location, and move to location. We'll plug these guys in, remembering that they need to be in order. We will now connect the values together. The way to do this is to go back over to the task and click the eyeball. Compile and save that, and do the same over here for both tasks. And now when we go over to the behavior tree and click on the task, you can see here the location key has become exposed. So now we'll go over to the blackboard. We'll create a new key for this to be saved, and we'll call this location. So let's get task location, click the drop down and select the location. And the same here, we'll click the drop down and select the location. So this task here, task get location, is essentially setting that blackboard key, that variable, and this task here is reading that or getting it. So we have essentially another version of a setter and a getter. So let's save that, come over to the test map and hit play. And this enemy over here is moving around. And every 5 seconds, he's going to get a new location. And as a perfect example, you can see here that he's actually run into our shotgun. And so he's failed. So the task has aborted. But another thing I'd like to draw your attention to first is that notice how these guys aren't moving. Every one of these is the same except for one thing, their location in the world. And old mate seems to have found his way around now, so that's good. Let me show you the difference. You may remember in the first episode, I said I was going to introduce you to 5 blueprints. They were AI controllers, blackboards, behavior trees, tasks, and the 5th one was a volume, specifically a nav mesh bounds volume, this guy down here. And if we were to select that nav mesh bounds volume, with that selected, if we hit P, this green area is the navigable radius of the AI. And so when this AI is deciding where to go, this is the area that it's considering. That's why we need the nav mesh bounds volume, because if I was to expand this area now, you can see that it turns red because it's trying to recalculate. So it's a pre-calculated area for which our AI can move. That's why we needed that in the first place. And I've just set it back to 5,000, so we don't need to overcalculate. But it's also taking into account edges. Say, for example, over here. It's taking into account the entire edge of the building and the edge of the platform. But these guys aren't in that navigable radius, so they can't move. So if I was to move them all in there, like so, and hit play again, now all of them will be moving. So our script is working, and everybody's moving around doing a random patrol. We're going to leave it there for now, again, to make this as digestible as possible. And then the next episode, we'll work on filling out this sequence here so that enemies will start chasing the player when they see them. Because at the moment, there's nothing to abort here. And if we abort, it's going to come back into this sequence here because that's all the selector has. So we'll leave it there for now, and we will pick up again in the next episode.